Welcome to today's webinar on Planes and SURPAC. My name is Alyssa and I'm part of the marketing team here in Perth, and with me today is your presenter, Ash.
G'day everyone.
Through today's session, we hope that you will learn about one of the lesser known features in SURPAC called Planes. Ash will talk about its benefits and uses, its advantages over classic slicing, and take you through some of the common workflows that utilize Planes. I'd also like to mention that due to some time constraints, we have pre-recorded some of the Planes functions, and we will be playing them as videos. We recorded these videos specifically for this webinar, so if you need any further clarification, please contact us. Now, I'll hand over to Ash, who will tell you a bit about himself.
Good afternoon everyone, and thanks for taking some time out of your day to come to the webinar. As Alyssa said, my name is Ash and I'm a mining and engineering surveyor based in Perth. I specialise in SURPAC, Mineshed and macros, and my hope is that even if you've been using Planes for a while, you'll be able to get some helpful hints from this webinar. A few weeks ago, I wrote a blog post about Planes, and because of the response we've had, we've decided to do this webinar. So if you like this format and would like to see more of these webinars, please let us know and maybe suggest a few topics of interest that we can cover. Also, head over to our blog for tips and tricks in SURPAC. Alyssa will let you know where to find it at the end of this webinar. So this webinar is to introduce you to Planes and show you some of the functionality available. We won't have time today to demonstrate all of the functionality, but hopefully from what you'll see today, you'll know enough to go away and put Planes to good use. Keep an eye out for more Planes, tips and tricks in the Geovia blog. The agenda for today is to show you general Planes functionality as well as some tips and tricks you may not have seen before. And it's really aimed at anyone who hasn't used Planes. But as I said before, even if you have used it, hopefully you'll be able to pick up a couple of things. I'll also show you how to find the Planes panel in case it is hidden, and also what options you have on the Planes toolbar and menu bar. After we've covered all that, I'll demonstrate how to use Planes. As I go, please type any questions you have for me during the presentation and we'll cover as many questions as possible at the end. So, what is a plane? One of the best definitions for them comes straight out of the SURPAC help menu. Put simply, planes are corridors in space used for displaying data. Anyone who has a version of SURPAC from 6.4 onwards will have access to Planes, as it is part of the core modules of SURPAC. So how do I find the Planes panel? I put this slide in as most users have a custom profile that they bring through from version to version of SURPAC. This means that some users may not have even seen the Planes tab before. If you're one of these users, getting the Planes panel back is very simple. Just go to the View menu in SURPAC and select Dockable Windows and then Planes. The Planes tab will then appear as an unobtrusive tab in the top right-hand corner of your SURPAC graphics window. If you hover your mouse over the tab will expand to show you all the options. Now, can you still use classic slicing? The answer is yes, and for some things it is still helpful, but eventually Planes functionality will replace the need for it. The main drawback with classic slicing is that it's not dynamic and must create actual strings when creating the viewing plane, and this can take a lot of time. So why use Planes instead of classic slicing? There are a few reasons for it. Planes are dynamic and don't create any slice data when creating the plane. The slice appears in graphics as a virtual string, which can be used by functions such as the digitizer, and also allows snapping to the virtual string. Because the slices are virtual, Planes are very quick to create and view. Planes can also be stored on your network and shared amongst your colleagues. This means that a site-specific set of Planes can be created once and then used throughout the life of the mine. Plane definitions will allow Autoplot to engage in batch plotting of sections by iterating through all Planes in a group. And Planes can also be used with SURPAC's Stope slicing tool, and this allows for quick slicing of a solid through any plane. For example, you could slice a large object by northing, and then you can slice that result by an easting, which creates much smaller carved solids. Planes also works with block models, and this is where some real speed improvements can be had. Even though the plane is dynamic and therefore no data is actually sliced, you can still interrogate and view the internal blocks in a block model. You can even display the grade of those blocks with matching colour block outlines. This is very helpful when designing or plotting. Let's have a look at the Planes toolbar. Now, I'll put this slide in as a reference for anyone getting the PowerPoint after the webinar, just so you can see what each of the icons does. The planes toolbar has a lot going on with it and provides the easiest way to set up planes and interact with any block model that might be open at the time. We'll be using most of these tools during the demonstration of planes, but there's a couple of things to note here. A plane has a viewing corridor or width associated to it. When you define the plane, you also set its default width. However, this can be changed using the toolbar. You see on the left-hand side on the slide, you've got plane corridor width, which can be adjusted. Also, the F11 and F12 keys allow you to step forward and backward through your plane group to allow easy keyboard access. On top of that, we have the plane's menu bar. Now, most of the options you will need when working with planes are on the toolbar, but there are a few planes functions hidden away in the planes menu that will also come in handy. The ones we'll have a look at today are the 3D work area. So once you've defined a plane, the 3D work area allows a 3D grid to be drawn around any data currently open, and will also show us the active plane, which can be seen as a translucent object. This makes it very easy to see where the plane intersects with your data. Another option we'll look at is create parallel planes. So if you're creating oblique planes, you first need to define the oblique plane that all other parallel planes will be based off. Once that's done, creating the rest of the oblique planes is easy with this function. You just need to nominate how many parallel planes you want. The last one we'll look at from the menu is save sections of string files. If you need to work with actual sliced strings extracted from objects that exist on a current plane, this function will allow you to do it. The way it slices the objects is really intuitive because only objects that are visible in graphics will be sliced, and the resulting string number will be adopted from whatever the object number was. So for example, a slice through object 10 will result in a segment being created that has a string number of 10. So now we've covered some of the theory to do with planes, we'll look at how to create them and make use of their functionality. So the first demonstration will cover how to create a plane through 3 points, and this is one of the easiest ways to create a plane. I'll also show you how to display the 3D work area, digitize onto the plane, and modify the corridor distances.
So by way of introduction to our planes, we've had a look at the planes toolbar already in the PowerPoint presentation. So this is where it sits over here on the right-hand side. When you first invoke it, it'll probably be nestled away like this. You just hover your mouse over that, and then you can pin it to the actual interface itself. So that's sitting over there, and our other options for planes that we also had a look at was under the planes menu just here. And some of the things that we were discussing was 3D work area, save section to string file, and so on. So we're going to cover a few of these as we go through now. But just a really quick one to start us off is to create a plane using 3 points. So if I go to the inclined menu here, you can see that there's an option to create a plane through 3 points. Just click on that one there. And what I want to do is basically just create a plane from, say, the floor of the upper level here, down to the backs on this lower level development here. And when I'm doing this, if I press F1, it puts it in pause mode, and I can rotate my data around, press escape to get out of pause, and then I can continue selecting my 3 points. So I'll just choose those 3 points there. And now that's actually created. So you don't see anything on the screen at the moment because we're not actually in 3D work view. So to do that and see the plane, just come back up to the planes menu, go to the 3D work area, and we're going to set the 3D work area on the open data. So now you can see the plane quite clearly as that translucent blue object. Now we have the plane there. It's not currently saved. It's still dynamic. So we can use it though for doing whatever we need to do. We don't have to actually save the plane. So what I'll do is I'll digitize onto this plane just to show you how that's done, and then we'll go ahead and save that plane later on. So to digitize on it, maybe what I'll do is create a new layer. Just call it the design layer is fine. And the only thing I need to make sure I do before I start digitizing is just ensure that this little box here is checked. So this is under the digitizer properties. So go in there, check that box, project selections to the current plane, press apply, and now all my digitizing will be pushed down onto that translucent blue plane. So invoke my digitizer, either using D on the keyboard or create new points using the mouse. And then come along here, and I'm just going to digitize some random points around here just so we can get an idea of how it works. 0 to close it off. And if I rotate that around, you'll see how that is actually digitized and pushed all those points down onto that particular plane. So let's say, for instance, I wanted to actually save this plane, utilize it later on, come back to it. I have to save that particular plane to do that. So in the planes menu, come down to where it says save current plane as, and let's just call it design 1. I've already got a group there called design, so design 1, and we'll call this plane number 1, and apply that. So this now has been saved. And if I come over here to my inclined planes panel, this is for horizontal or plan view planes, and this is vertical, but these are my inclined ones. There's my design 1, and this number 1 here is the plane that we're looking at on the screen. So I can make that active just by double clicking on that. And when I do that, I can now use some of these tools up here. So for instance, I might want to see just a polyline of where that plane intersects all my objects. So to see that, I just click on this little button here, and I'm now getting a polyline view. So this is quite helpful if I'm doing any design work and I want to hide away the triangles and snap onto my my virtual strings, because these are actually virtual strings. They're not slices. So that's how planes work so fast as well, because everything's done in a virtual string environment. If I want to get back to how it was before, I can just press this polyline one again, and it takes me back out to that. Now, when I'm in the polyline environment, what I might want to do also is set my current plane to be in the 2D environment, and that allows me to utilize all my digitizing functions as well. Once I'm in here, you might also want to reverse the viewing direction of your plane. So if I click on this one here, it spins me around and reverses the viewing direction. And just click on it again to go back to the original viewing direction. And to get out of it all, just polylines again, and click on the 2D grid again, and we're back out to where we were before. So it's just a little introduction to planes. Some of the other planes functions which we'll cover are inside this quick planes menu here, and they're all the standard ones. So you can do a northing, easting, elevation, and then you can have your oblique planes here and create parallel planes from that as well. So we'll cover those off as we go through this demonstration.
So the next demonstration will cover creating planes along a centre line. This is not a current function in the planes menu, but what you can do though is create a plane by dip and dip direction and store these values into points that are located anywhere you would like a plane. Using a small macro, we can then loop over all of those points and create a plane by using the stored definition. This works really well and saves a heap of time. We can also get the plane to dump forward, similar to the workflow of creating ring design slices.
So what I want to do now is just to show you how we can create planes along a centre line, a predetermined centre line. So I've brought in my lower level development here. I've just got a scope object in here for interest, and you can see my black line coming across here. This is the centre line that I want to create my planes along. I've already used another function to subdivide this particular centre line. So if I type in PM for plot markers, you can see that I've divided my centre line into even increments, and each one of these points represents where I would like a plane to be defined. So the way that I'm trying to do it is to basically dump my plane forward in this direction here. In this case, I want to dump it forward, say 20 degrees, and I need it to be perpendicular to that particular centre line that I have here. So I already know that my center line is coming along an angle of 340 degrees, and I want my plane to be dumped forward with 20 degrees from the zenith. So what that means is that I need to specify a dip direction of 160 degrees and a dip angle of 70 degrees, and that will give me my desired result. So to create this plane, I need to do it manually in SERPAC at the moment, and I would have to actually do it for each one of these particular points along my center line. So if I wanted to create them all, I think there's about 32 points here. That means I have to do this 32 times as it currently stands. What we've done is we've just created a little bit of a macro that loops over each one of these points. We've already written the dip and dip direction into these points using some string math, and the macro extracts out that bits of information, puts it into the dip and dip direction planes function, and will automatically create those planes for me. So I'll show you how to do it manually first, and then I'll show you how to do it using our automated script here. And these are freely available for you guys. Just email me and I'll send them out to you. So to do it manually first, we go to planes, and we go to inclined planes, and by dip and dip direction. You'll see down the bottom here it says select the first point for the inclined plane. And I'm just going to populate the dip angle and dip direction with 70 degrees and 160 as we discussed before, and then press apply. And there is my plane definition. So you can see that it's perpendicular to my center line, and it is dumping 20 degrees forward like I wanted it to. So as we spoke about before, I would have to then go to the next one and the next one and the next one and use that same function to create all these planes along the center line. But we're not going to worry about that. We are going to use the automated function, which is under my extra planes menu here. So I need to be able to see my actual center line string, the first and last point on that when I run this function. So I'll just click on extra planes and create planes at any dump angle. And it's going to create it from these user inputs that I've told you about before. And we're going to start our dump at 0, so at the zenith, and it's going to progressively travel through to the very end point, which is point number 33 on this string, and that'll be a final dump angle of 20 degrees. So if I press apply on that, it now asks me, okay, what do you want to store these planes as? So I'm going to store them as dumped planes. And I'm going to start my segments at number 1. So down here is number 1, 2, 3, and so on. So press apply on that, and SERPAC goes away and calculates the dip and dip direction for me. So now that that's done, I'll bring back my objects so you can see them. And let's now visualize those planes. So that's been created. They are inclined planes. And you can see that I've got a plane group here called dumped planes, starting at 1, going all the way to 33. And I can start at, say, number 1 here. You can see that it's a vertical plane. And as we go through these planes, they should progressively dump over. So let's visualize these using another automated function we've written. Visualize planes. So we're going to visualize the dumped planes at a speed of 0.3, press apply, and that will just travel through all these planes here. You can see that it's progressively dumping over. When it hits the final one there, that's where it'll be at the it'll be at the 20 degree mark. So I'll spin my data around. You can see that it's sort of probably about the 10 or 11 degree mark there. I jump down to plane number 33, spin my data around. That's now at 20 degrees just there. So that's how we can create some planes along the center line.
So it's sometimes necessary to move and rotate a solid in SERPAC, but the traditional tools for doing this make it quite a hard task. Once you've defined a plane, rotating the data about the plane is actually very easy. You just need to show the point markers that make up the object and use the edit move string constrained by rotation function. This next demonstration will show you how it's done.
want to demonstrate now is just how we can rotate data or an object or a solid using planes functionality. So the plane type that I'll set up will be just plane through 3 points, and I'll just be using this shape here, this CMS shape. So one of the first things I'll do before I activate my plane is I'll just put out my markers, and you'll see the reason for that in a second. And now if I just go through planes, inclined, plane through 3 points, and let's just click somewhere here, somewhere there. So I've now defined my 3 points. So going on what we've learnt so far, I can go back to planes menu, click on my 3D work area, open that up, and if I rotate that around and just so you can have a look, you can see here I've got my plane definition going through those 3 points just along the back edge of this stope. So I want to rotate my data about that angle, and the way that I do that, and the reason for bringing the markers up, is that my triangles are all part of, or all attached to a string file, and essentially that string file made up of lines and segments and points, and I want to be able to rotate using that string file and have all the triangles follow it. So I'm in the DTM layer, which is what I should be in, and I'm going to use a function called edit. Down the bottom here, we got move string constrained by rotation. So it says digitize the pivot point to rotate about, and I can just come over here, click somewhere in the middle of the object, and then I can click and drag about that pivot point. But you'll notice that it stays constrained to the actual plane. So if I rotate or drag my mouse sort of up and down like that, you can see that it's sort of sticking to that plane. Doesn't matter how far to the right or to the left I drag my mouse, it's staying to that plane. Same if I go up and down, it's staying to that plane. So let's just rotate it down here somewhere, let go. It says this is the angle that you're going to shift it, that's fine. Press apply, and you'll see that it's actually shifted about that plane. Okay, so it's actually dragged that down, rotated that down. So now what I want to do is change it again and rotate it around on this side of the object. So let's just create another plane through 3 points. And I'll choose somewhere here, and somewhere there. And let's just rotate our data so we can get a better view of how it's spinning. And let's go back to that function. So edit, move string constrained by rotation. Click somewhere in the middle, and then anywhere else to just rotate. You can see it's now rotating about that plane there. Apply that change, and there it is. So another very handy feature to do with planes, because it's very hard to actually do that with any other type of function inside SERPAC.
So this next demonstration shows how to create a section string file through all visible objects using a stored planes definition. I also discuss how to use the drafting tool with virtual strings, which can make tasks like slicing a CMS very easy. What's even better is the fact that the objects don't need to be valid to create slices of them.
So what I want to do now is just show you how we can create slices of our data through the objects. So I'll just bring in my stope, and I'll bring in my lower level development here. And we're going to be using some planes that have already been stored just to show you how we can put these on a network or share them with colleagues, and then anyone has access to them. So the actual planes we're going to use are the ones we created before, which are just the dumped planes. So I'll just bring those out, and let's just have a look at, say, plane number 1. The actual corridor definition of plane number 1 is very wide at the moment, so I'm just going to set that to be 1 and 1 to give you a better idea. And then if I put that into, say, 2D view, and then we can even draw the polylines for it, and you can see that we have our section. So when this gets saved out, my section string file will honour the object number or the string number of the sections that get saved. In other words, any object that has object number 1 will create a string in the the section file as string number 1, object 2 will be string number 2, and so on. I also just want to show you, before we go ahead and save a single section, just how we can use the virtual strings, which is what these are on the screen, to snap to and do things like digitizing work and even use something called the drafting tool. So what I'll do is I'll go ahead and invoke my digitizer. I'll right click on the screen and set it to snap to line mode, and I'm just going to digitize a point on that line, and you'll see as I drag my mouse around and snapping to the actual line. So I'll just digitize a couple of points going around here, just roughly, and then when I get around to the left hand side of this shape, I'll show you how we can do the drafting tool. So if I just pause it there and go right click on the screen and then drafting, you'll see some measurements come up on the screen. I've got a distance of 6 and an angle of 95 at the moment. As I go around, the angle increases. So that's all based off this line here that I've just finished digitizing. If I want to do my offset snap, which is what I want to do here, I need to hold down Control and then right click on the segment or string that I want to do the offset from, and that's highlighted in green. So as I move my mouse out, you'll see that that measurement continues on. So that's 11 meters there. So I can now digitize at an even increment, and this distance can be whatever I want. And you set those distances in the tool properties box over here, and you have a distance for offset snap, the distance snap, and angle snap. So I'm just going to roughly digitize up here. You can see the points getting created at those even increments, 11 meters all the way there. 10 meters coming in, 9 meters, 8 meters. So this is a really good way if you were doing, say, some sort of stope design, you had your block model up and you needed to make sure you were honouring a minimum mining width. You can use the offset tool with drafting. So now that I've created that, I could do whatever I wanted with that, but I don't need that string. I just wanted to show you what was possible there. So I'm actually going to just delete that, edit segment delete. And now what I'm going to do is show you how we can save out this virtual string to a section string file and possibly use that for whatever we want to. So to do that, I will just jump out of my planes definition, and I'm still have plane number 1 as the active one, section number 1 as active, sorry. So I'm going to now run a function called planes, save section to string file, and let's just call this plane 1, and then apply. One already exists, so I'm just going to override that, that's fine. So that one's been created for me, so let's just go and find that in our navigator. Here it is here, let's drag that in and find it. And you can see that plane number 1 has now been created as a string file. So if I hide away my lower stope and lower level development, you can see the actual string itself has come through. You'll also notice that object number 1 has been created as string number 1. Object 2 is string number 2. So if I just do an inquire point properties, you'll see that. Down there we've got string number 1 and string number 2. So if I was to create sections of all these individual planes, I would have to then double click on the next one, go into my planes, come down here and go save section string file. Obviously that's going to take quite a while if I've got a lot of planes like I have in this group, 33 of them. So what we did was we just created a little macro that will loop over all of these planes and basically run that function and save it out for us into a particular folder. So if I just enter my plane definition and bring back my objects, and I'll even get rid of this string file here, delete it from there, and delete it from my navigator. And let's create a whole bunch of strings into a dumped planes folder. So I had created these ones before, so I'll just delete that folder and get rid of it so we can see it happening again. So if I now go into my extra planes functions, and I'm going to create sections through objects using planes, inclined, because that's what these ones here are. They're all in an inclined plane group. Click on that one there, choose the plane group I want to create them from, which is dumped planes, and then I just type the folder name of all the section strings where that's going to be created. So I'll also create that into a dumped planes folder and press apply. You'll see SERPAC will iterate through all the planes here that are listed on the right hand side in the plane group, dumped planes. And each time it's looping through, it's using that function, save section to string file, and it's creating these planes as a section string file for me in that folder we just created. So if I now go over to my dumped planes folder, you'll see that I've got from 1 to 33, which is there. Let's just bring all of those in. And my main graphics layer is already set. So if I just drag those in, hold down Control, all of these ones will be brought into my main graphics layer. And now that's done, let's just hide away my objects again. And I'll even enter my plane definition, and there's all the strings there. So let's say, for example, I was only interested in this drive coming out through here, all these dump strings. I wasn't interested in any of this. What I can do is use my box select tool. So if I rotate my data around so that I can select it easily, I can then use this function up the top here called box select points. Click on that one, drag a box around the data that I don't want, and then right click on the screen once it's selected and press delete. And they all get deleted off the screen. So that's just a good demonstration of how we can save out section to string file, and we can also use the automated function that you can get in the free installer kit. Just email me some details and I'll send it on to you.
So I put this next demo in just to give you an idea of what can be done with the planes functionality with just a small amount of scripting. It was actually a customer request that we're able to do and is also part of the free installer kit.
So here's an example of what we can do with just using some of the existing planes functionality in SERPAC, along with a small amount of scripting. And if I just bring in my design, hit design here, what I am going to do is create planes that are going to rotate about a centroid. Now, there's a number of different ways that I could do this manually, but probably the way that you would do it is come into planes, go to inclined, and you'd be creating a whole bunch of planes using different dip and dip direction values. So you can create all those manually and then have them all in a plane group and then utilize them from there. But what we ended up doing was basically automating that process, and just with a small amount of scripting created a extra plane function called create planes radiating from a centroid. So if I just run that function now, create planes radiating from a centroid, it just asks me to select the centroid position. You can choose anywhere in the object, it doesn't really matter, it's just going to be where the planes intersect. Now I'll give it a plane group name of centroid. That's what's going to get created over here in the vertical planes. Don't need to worry about a suffix, it's optional. The bearing of the first plane is 0, so 0 degrees. If I have a bearing of 0, a step interval of 10 degrees, and a number of steps of 17, that basically is going to give me a 360 degree view of my pit in 10 degree increments. And you'll see how that works in just a second. So if I press apply on that, you can see how it's spinning around in the view there. It's finished on this plane here. And if I go over to my planes definition, you can now see that in my vertical planes, I've got one called centroid, and in there I've got 0 right through. So every 10 degrees, one is getting created. 0 is the true north plane, so 0 to 180. 10 degrees over here is obviously 10 and 190. If I go down to 20, we've got 20 and 200, and so on. So it's cutting right through the object through there, and using these planes now, we can obviously create section strings from them. So if I come up to my extra planes function, I can use this function here called create sections through objects using planes, and that's the vertical one. Click on that, and I just choose my centroid plane group to create sections from. I'm going to put these in a folder also called centroid. And then just press apply. So Serpac's stepping through each one of these planes now. Each time it does, it'll create a new section string file for me. And over here, I've now got a folder called centroid. And in there, I've got my plane definitions saved out as strings. So I'll just set my active layer to the main graphics layer, select all my strings, and I'll bring them all in so we can see what they look like. So I'm now set at the moment on my 90-degree plane. So if I go back into plan view, you can see that quite clearly on the screen. And you've got all my section strings going around my entire pit. So let's have a bit better look at that. Just by hiding my pit, you can see the strings showing there. So this is just a small little example of how we can use existing planes functionality with a small amount of scripting and create a function for a client that's proved quite useful for them.
So using planes with a block model is really easy and very quick. In fact, this is where most of the speed improvements over classic slicing can be found. In this next demonstration, I'll show you how to display block outlines coloured by attribute, along with the grey belly of the block displayed at the centre.
So what I want to demonstrate now is how we can use our planes in conjunction with a block model. So I'll just bring in some design data to start off with, and then we'll connect to a block model, and then we'll just display all the blocks in the model. But you'll notice here I'm not going to check this include internal blocks little checkbox here. What that will do is actually display, or Serpac will display all the internal blocks, even the ones that I can't see, which is quite memory intensive. But you'll see that when we use our planes, we'll still get access to all these internal blocks. So there's my model covering my design here, and I've created a constraint that I'll just drag into the graphics here. And this is any block with some sort of grade in it will be displayed on my screen. And now what I want to do is just colour this model up by that gold attribute. That range is fine. Just press apply. It'll give us an idea of how this works. So I've got some colour on my blocks. My model's loaded in constrained. Now what I want to do is use some of the functionality that's on my planes panel here to be able to view the internal blocks with the grade contained at the centroid of each of those blocks. Before I do that though, what I need to do is create some planes that will cover the data that I want. So I'll just work out the data extents. And you're looking at a minimum here of 45 to a maximum of 255 just by using the inquire report layer extents. So I don't want to create all those slices. I might just go from 100 to 200 every 10 because my bench height here is 10. And the way I can do that is either coming into this function here, which is quick planes, or you can get access to it through the menu as well. Clicking on quick planes there does the same thing. So I'll come into here, set it as elevation, and I'll do a start, end, and interval. My start, as I said, will be 100, and we'll go to 200 every 10 to match our bench height, and I'll just get a 1 metre by 1 metre viewing corridor. And let's just call this plane group pit slices and press apply. So you see over here on the right hand side in my planes panel, I've got my pit slices going from 100 to 200 every 10 metres, and I've got my slice coming through here like this. So let's jump to say the 150 elevation. And let's have a look at how we can view the grade at each one of those centroid positions in these blocks. So as I zoom in here, we've got our block outlines. So what I need to do is use some of this planes functionality up here. And the first one I'm going to use is to draw a block model as blocks or polylines. So if I click on this one, get to this shape here. And what I want to do now is apply a bit of shrinkage. So I'll just put in, say, 2.1 with my shrinkage. You can see that each of my blocks is now separated out. And this is helpful when we get to the next step where our block outlines are just displayed as strings. We're not going to have any overlap of colours where we've got two different grade values sitting next to each other. So I'll come into my next icon here, which is display attributes on section. Click on this one, and we're doing the gold attribute at the center, object relative units, and apply that. Okay, so you can see now that at the centroid of each of my blocks, I've got some grade range specified in there. So that's just a few little tips and tricks with how to display some grade values at the centroid of each block. Now, of course, if you want to back out from all that and get a full view of all your data, you can just use the Set Large Projections button, and you can see how that actually sits inside your pit.
So now that we know how to display grades and block outlines using planes, we can take it a step further and split the viewport so that we can utilise a 3D view in one viewport and a 2D view in the other. When I perform tasks such as digitising in the 2D viewport, SERPAC will automatically update the 3D viewport, allowing for a more comprehensive view of the work I'm doing.
So what I want to do now is show you how we can utilise planes with splitting the viewport so that I can be doing work on one viewport and seeing a dynamic update happen on the other viewport. So this example, what I'll do is I'll bring in my design and I'll display my block model. And while I've got it at this point, I'm going to split my viewport. So if I right click on the screen, you'll see there's a viewport menu that appears, and I've got some options here, and the option that I'm going to choose now is to split vertically, although I could split it horizontally if I wished. And this gives me an identical view of my data in both viewports. So once we get it to this point, what we need to do is actually pay attention to this green outline that's around my right-hand viewport at the moment. This is telling me that the right-hand viewport is actually the active viewport, and I can change which one is active just by left-clicking in either viewport. Now, the reason that's important is because when I start using the icons and functions on my planes panel, it is going to work only on the active viewport that I set beforehand. Now, before I do any work in the planes panel, I'm going to open my 3D work area. So if I click on 3D work area on the open data, this will affect both viewports, and it opens them both up. And what I want to do is have my left-hand viewport show me a three-dimensional view of my data and my blocks in space. And on my right-hand viewport is where I want to be doing some digitising. So I'm going to work on the 140 elevation for both. So on my left-hand viewport, I'll double-click here, and that'll take me to the slice. And what I'll need to do to bring back my 3D work area is just to set large projections. So I've set my large projections here, got my 3D view, so I'm happy with that. On the right-hand viewport now, it's also set at the 140 elevation. And I'm going to put that into the 2D view just by clicking on this button here. So now I'm in 2D view. I want to run through the same process as we've done before, which is to change those into blocks and then apply some shrinkage. And now that I've applied that, I'm going to display my grade attribute at the center. So choose my attribute, position center, apply that form, and now I can see all my grades. So this is pretty much how I want my view to be. I'm just going to now digitize in this left-hand viewport, and I should get the updated digitising line come through on my left-hand viewport here. So before I do that though, I want to just increase the thickness of my digitising line so it's much easier to see. So I can go into my styles, change the thickness of string 1, apply that, and now that's done, I'll go into my digitiser, and let's just start digitising a line from here, and you'll see down in on the left-hand viewport, this is where it's dynamically updating just through here. So as I keep digitising away, you'll see the update coming through on the left-hand viewport. So it's just another very handy function that you can utilise with our stored planes, just reactivating a stored plane. And then you can see by splitting the viewport, we've got a dynamic update on the left-hand viewport as I work away on the right-hand viewport. 2D mode on the right-hand side, 3D mode on the left-hand side.
So the last of the features that we'll demonstrate today is using planes with autoplot. Once we have defined the planes, we can utilise them at any time to do batch plotting of sections. This final demonstration will show you how this is done.
Okay, so this final demonstration will be showing you how to do batch plotting with planes. And to do that, I'll just drag in a little bit of data, including our database. So in my database here, I'll just display the drill holes with some pattern. And I'll also display it with some sample table information. So I'll apply that, no constraints. There's my drill holes with the pattern down the left-hand side and some drill hole information on the right-hand side. So I'll bring in a topo and pit design as well, just so we can have a bit of a look at it and how that works with planes. And if I come across to my planes panel, I've already defined some planes by northing, going from the 7200 north to the 7400 north. And let's just click on 7200. Put that in 2D view, and we'll also just draw the polyline through there. So these are the planes that I'm essentially going to be plotting through, 7200 to the 7400 every 40 metres. And to do this properly, what I needed to do was create a reference line, and that basically maintains the drill holes central to the plot window as I go through my batch sections. If you're unsure how to do that, you can just contact us and we can take you through that process. So all I need to do now is go into the plotting window, auto plot, and let's give the plots a name. So I'm just going to call this, say, drill hole sections on A3. 1 is to 2,500 will be fine. We'll do a 2D grid and on a normal NMA3 title block. And then I just need to set up these two here. So I want a plan strip where my drill hole collars are, and I also want my batch sections. And this is where I can choose which planes out of my plane group do I want to actually plot. So it's optional, but I'm going to plot all of them, and I'm going to have them relative to this reference line, which will just adjust my plot window as it goes through the sections. So I'll press apply on that now. This is also optional. I can put a title in here, and now it comes up with my plot window. So I'm just going to accept that by pressing F2 and do border ticks my grid lines, and Serpac's now going through and plotting those sections based on my plane definitions over here. So that's now done. As you can see on the left-hand side here, I've got my drill hole sections, that's what I called it, and planes has actually appended the plane name to the end of my actual plot file name, which is very helpful. So if I now drag in one of those files and have a look at it, you can see this is basically the final result for the plot. Let's have a look at the last one. You can see how the drill holes are still central to the plot, and that's based on my reference string line. So this is just a final demonstration just to show you another functionality with your planes.
All right, thanks, Ash. Now, I've seen some questions pop up from the audience, so we will take them now. The first one is, if I store my planes on the network, how do I get access to them?
Okay, so if your planes are on a network and you happen to be shifting around between computers, I'll just bring up Serpac here, you can go to the Customize menu and down to Default Preferences. I'll drag this across the screen. And in there, you can see there's something called alias files and translations. So one of the ways that you can point SERPAC to where your planes are stored is just by coming in here, going to where planes is referenced, clicking on this little box here, which opens a browser, and then you can navigate to wherever your planes are stored.
Great, thank you. And another question here, how do I stop someone from deleting a required plane group if they are stored on the network?
Okay, so SERPAC works with Windows security permissions. So basically, if you do have your plane stored on a network like any other file, it'll come down to what permissions the user has. So if they have full read and write access to that particular folder where the planes are stored, then they'll be able to delete the plane definitions. So you just need to work out with IT your user permissions for that one.
Great, thank you, Ash. And one more here. How do we pause in between the commands? For example, while using the inclined plane through 3 points, how do we pause in the middle of this operation?
Okay, so during the demonstration I covered this, but I'll just run through it quickly again. So if you go down to planes and inclined, and we're going to do by through 3 points, sorry. So with any of these functions here, if we want to pause it while we're doing it, all I needed to do was press F1. So I'll just run that through again. Planes, inclined, plane through 3 points, or any of these other functions. And then press F1 and you can pause it as you go.
So where to from here? If you require any assistance at all with planes, or if you'd like us to review your current workflow, you can contact us at geovia.support@3ds.com, or Ash's email is listed there on the screen. And also, we hope that you can try the planes functionality out for yourself and play around with it. We encourage you to upgrade also to the latest version of SERPAC, which is 6.7.4, that was released last week. They provide over 50 updates and enhancements, including the new circumcircle function, improved graphical rotation of data, improved memory management, and also changes to the solid surface intersection function. This new release was developed with input from our user community, so we're always looking for feedback from you. Please participate in our beta testing program and also log your enhancement requests with our technical support team. And lastly, keep up to date with us on Twitter, Facebook, LinkedIn, and the Geovia blog. On the blog, we do have a few posts on planes, so please check them out by typing planes in the search bar on the blog. And more will be coming soon, as well as information on many other topics. And it would also be great if you could take a few minutes to provide some feedback on your experience, what you liked about the webinar, what topics you'd like to see in the future. A survey should pop up after you close the session. And there are also quite a few email addresses listed there. If you need any further information on specific services or products, technical queries, or upcoming training classes, you can contact us. And as Ash mentioned, the macros that he mentioned today, if you are interested in having any one of them, please email Ash. Well, thanks everyone. Thanks so much for your time today, and we hope to see you again at the next one.
Thanks very much, guys, for listening and taking the time.